Hi there, and thanks for tuning in. This is going to be your Chapter 11 CSA review, and we're going to go and get started with number 1. The first one is going to be a rotation, because the two letters have been rotated or turned. Number 2 is going to be a translation, because the two shapes have been slid over. Number 3 is a dilation, because the shapes have increased in their size. And number 4 is a reflection, because the shapes have been flipped. For number 5, the two figures are not congruent because they are not the same size. Remember, congruent figures have to be exactly the same shape and the same size. In number 6, these shapes are not similar because the sides are not proportional. Remember, for similar figures, your sides must be proportional. If you put 8 over 5 and 6 over 4 and cross multiplied, you get two different numbers, which means they're not proportional. You can also see that 8 over 5 is not equivalent to 3 over 2, which is 6 over 4 reduced. For number 7, on the next page, you're translating the figure 4 units right and 6 units up. This is easy because all you have to do for each individual point is count 4 to the right, 1, 2, 3, 4, and 6 up. 1, 2, 3, 4, 5, 6. So that means J prime should be at 2, 4. H prime, which is the first point on your list, should be at 0, 3. All I did was to go 4 to the right, 6 up. K prime should be at 1, 1. And L prime should be at -1, +2. When you connect all your points together, the shape should still look the same, except just slid up a bit. For number 8, you're reflecting over the y-axis. Again, keep in mind the y-axis is the vertical axis, so all of your x-coordinates will change. You have 3 points that you're supposed to label as well, G prime, H prime, and J prime. G prime is going to be at -4, +2. H prime will be at -1, +4. And J prime will be at -3, +1. When you connect your points, your triangle is reflected over the y-axis. Number 9 is a little bit tricky for some people. An easy way to remember how to rotate a figure 180 degrees about the origin is to just continue the pattern of how the point gets to the origin. I'm going to start with point Y just because it's closest. If I go down 1 and over 2 for my coordinates, I'm going to continue that pattern and go down 1 over 2. So here would be point Y. Okay? So you have your 4 points VW, X, and Y. And we're already going to say that Y is at 2, -1. So V, let's start there at the top. I had to go down 1 and over 3 to get to the origin. So I'm going to continue to go down 1 and over 3 on the other side. V prime is at 3, -1. X, let's start with W. Down 6 over 5, so we'll keep going down 6 over 5 for W. That one is 5, -6. And then X prime, we went down 6 over 4, so down 6 over 4 will be X prime. And that is at 4, -6. Connect your dots together, and your rotation has been set. For number 10, you're supposed to dilate with a scale factor of 2. An easier way to maybe start is to figure out what all of your original points are first. What I've gone ahead and done is just listed my original points, and that is going to help me establish where my new points will go, because if I'm dilating with a scale factor of 2, that means I'm going to be taking each of those numbers and multiplying by 2. So t prime will be -6, +4. V prime will be 6, +4. W prime will be 6, -4. And x prime will be -6, -4. Connect your dots all together, and you will have a larger rectangle exactly 2 times the size of your original rectangle. Okay, so once again, it's easier to start with your original points and then multiplying them from there. On our next page, we have number 11, and identify the type of dilation as an enlargement or reduction, and then find the scale factor. Notice that the original point W is here, and the new point W is here. So it definitely reduced. That's a reduction. And then the scale factor, all you have to do is start from where you originally were. So point W was -15, +15, and W prime went to -3, +3. Notice that 15 can change to 3 by dividing by 5. Since we divided by 5, our scale factor needs to be smaller than 1, so my scale factor is going to be 1/5. 1/5 would be your scale factor. Okay. For number 12, describe the translation from the shaded figure to the unshaded. So we just have to count how many points it moved. We went, you can either start going right or going down. I'm going to start going right. We went 1, 2, 3, 4, 5, 6 to the right. I noticed they're in the half step, so I just counted each individual half step. So we went 6 to the right, 6 units right. And then we went 1 unit down. If you might have switched these around, 1 unit down and 6 units right, that is totally fine, just as long as you have 6 going right and 1 going down. Number 13 has 4 parts to it. The polygons below are congruent, so we're going to use the diagram to help answer the questions. The side of LM is also congruent to side DC, so that means DC and LM both are 7. The angle of LM and PQ corresponds to angle F is going to be angle P. Here's angle F, here's angle P. The side MN is congruent to side NP. What is the length of MN? If I look over here, MN is congruent to DE, and that means DE is congruent to EF. So that means both or all of these sides are going to be equal to 18. The last part is the perimeter of the entire shape. Notice that CDEFG is missing one single space now, and that's here. It corresponds to LQ, so we're going to say that's 14. So what we had to do to find the perimeter, 7 plus 18 plus 18 plus 11 plus 14. Adding all these numbers together, we should get 68 as the perimeter. Going on to the final page of your review, number 14, the polygons are similar, so find the value of x. Remember, similar polygons have the same ratio for corresponding sides is equal to the ratio of the perimeters. So what I can do here is take both of these and write a proportion because these sides should be proportional. I know 14 times 20, or you can say 14 times 2, is going to give me 280, and 8 times x is 8x. Divide both sides by 8. X is equal to 35. Okay? For number 15, this is where your sides come into play. The ratio of the perimeters is 3 to 8. So that means it's also congruent to x to 12. Okay? 3 to 8 is equal to x to 12 because these polygons are similar. They should have the same ratio for the corresponding sides as their perimeters. If we cross multiply, 3 times 12 is 36, and 8 times x is 8x, and then you just divide both sides by 8. Now 8 does not go into 36 evenly, so what we have here is we're gonna get a decimal of 4.5 as our answer. For number 16, we're talking about a reduction. The scale factor is 1/3, so that means you're just going to divide both numbers by 3. So if you look at the numbers 18 and -9, if we divide both of those by 3, we're going to get 6 and -3. So C prime is equal to 6, -3. The last one was a bit challenging. You have the corresponding side lengths of the MP3 player is 4 to 3. And the larger MP3 player is 8, and we're just trying to find the missing piece here. What we do know is that whenever we have the corresponding sides ratio, what we're going to do to find the area ratio is we're going to square it to get the areas ratio. I know for sure that 4 cannot be squared to make 8, but what I do know is that if I square this 4/3, so multiplying it by itself, I'm going to get 16 over 9, okay? And 16 over 9 needs to be equal to this because this is the area that's going to be showing on the bigger MP3 player. So what I'm going to need to do is just to figure out how 16 over 9 relates to 8 over x. Maybe even one way you can see it right now is that 16 can be divided by 2 to get to 8. So what we can do here is divide 9 by 2 to get our x. 9 divided by 2 is going to give us 4.5. So my answer for number 17 is going to be 4.5. That's the area of the smaller MP3 player. That's going to conclude our review for today. Just make sure that you are understanding all of the following concepts in Chapter 11, and maybe even check out the practice test that I've given you the code for while you are in class. Thanks for tuning in. Good luck on your test.